Good morning, all. Is my screen visible? Okay, in past lecture, we started with neighborhood and adjacencies of the pixels. I won't revise what we have finished because I revised it already on the Monday's lecture where we had poor electricity and we skipped that lecture which was conducted actually at the lab lab timing. So we skipped that lecture and I said that we'll continue the remaining part in today's lecture. So we already discussed what is four adjacency, what is eight adjacency. Four adjacency means there should be four neighbors available, and all of them should be from the set V. And in eight adjacency, uh, the pixels P and Q are said to be eight adjacent if they are eight neighbors of each other, and both the pixels should be from the set V. Okay, so the very simple definition. We can understand it very easily if we see practical examples later. Then the third is M adjacency, that is mixed adjacency. Mixed adjacency means you will have sometimes four adjacency and sometimes eight adjacency, but it is not like you prefer either four adjacency or eight adjacency the way you want. It's not like that. Here there is something called as a priority. So you first see if there is four adjacent pixel available. Four adjacent pixel means what? Either in the vertical or horizontal direction if there is a neighbor. If there is a neighbor, you choose that neighbor first. And uh, other way is if four neighbor is not possible or not available, you see if there is diagonal neighbor available. If diagonal neighbor available and the pixel P and pixel Q has no four neighbors common between them, that is N4P and N4Q. These two sets are not having any common element, which is the part of a V. Then we see that these two pixels are M adjacent. So what is condition for M adjacency? Either those two pixels should be four neighbors to each other, or the pixel Q should have diagonal neighbor of pixel P, and they should not have any fourth neighbor common between them. So if they have fourth neighbor common, then directly we can say that they are in adjacent. If this is not true, then we go for this. So in this case, if they are diagonal neighbors of each other, then their intersection should not have any common element which is from V. Otherwise, we are not talking about this definition. We are talking about this definition. If they have the common neighbor in the fourth neighbor, then this condition we are basically talking about, right? So here, M adjacency means either they will adjacent because of the fourth neighbor, or fourth neighbor is not common and they are adjacent because of diagonal neighbor. So here there is a priority on the adjacency. If you first look for the fourth neighbor or fourth adjacency, if that is not true, then you look for the diagonal adjacency. And in that case, if you find the diagonal adjacency, then this collectively called as M adjacency. So we will see example later, and then you will understand in a better way. The another definition is path. Path means uh, the line which can be drawn between pixel P and pixel Q. Let's say pixel P having coordinate x0, y0, and pixel Q is having coordinates xn, yn. Then pixel x0, y0 to pixel xn, yn. Suppose I sketch some image like this. I'm calling this as an image because every box represents one pixel. I hope you remember, every box represents one pixel. So suppose pixel P is here and pixel Q is here somewhere. And if I sketch a line running from P to Q, going through these pixels, this one, I don't know what these pixels are. I'm making question mark. So whatever it may be, whatever those pixels may be. So I have a connection between pixel P, which is located at x0, y0, and pixel Q, which is located at x and y through various other pixels in between, which I don't know. I have marked them as a question mark. Then that link or that line which I have drawn is called as a path. So in path, every next pixel, suppose x0, y0 is a one pixel, then the next is x2, y2, and the last is xn, yn. The previous of this will be xn minus 1, yn minus 1. So one pixel, and just before that, this is the indication of one pixel, and just before that, they are adjacent for all the values of I. So when can I say this is a path? This is a path only if I talk about this pixel, then this pixel will be adjacent to that, as well as this pixel will be adjacent to that. Then when I talk about this pixel, the pixel here and pixel here should be adjacent to that. Then when I talk about this pixel, then pixel here and pixel here should be adjacent to that. So in a path, every pixel will be adjacent to every other pixel on that path, which is just before or after that pixel. Okay, you will again get to know in a better way when we will see the actual example later. So here number n represents the length of the path. So from the first pixel to, suppose path is of 10, then first pixel to 10th pixel, all these 10 pixels, if you see, then one of the pixel connected to the second pixel means they are adjacent. Then second to third pixel, they are adjacent. So this second pixel is adjacent to first as well as third pixel. Then third pixel is adjacent to second and fourth pixel. Fourth pixel is adjacent to third and fifth pixel, and so on. So the path may run also this way. It depends on how you are getting the adjacency. We will see later in the image. If the originating pixel in the path and the terminating pixel in the path, in this case P and Q, if both P and Q, where the path starts and path ends, if those two pixels are same, then we say that the path is closed. For an example, if I show you an image like this, suppose this is a pixel P, the path starts here. Let me show you the complete path. The path starts here, it goes like this, it goes like this, it like this, and like this, and ends again here, and this is also pixel Q. So in this case, starting pixel is P, ending pixel is Q, and those both are same. In that case, the path is called as closed path. As you can see, the path makes a closed loop, right? We can define 4 path, 8 path, and M path depending on the type of adjacency, that is 4 adjacency, 8 adjacency, or M adjacency. Okay, now to explain the adjacency and path, we take this example. This is a example image which has pixels 0, 1, and 2. And as I said, when discussing adjacency, we will be given with some set V, which will contain some of the pixels from the given image. So here, in this case, the image contains element 0, 1, and 2, and V set V is given, which is containing only elements 1 and 2. So now if I want to discuss about the adjacency and path between the pixel which is shown at the bottom right corner and top right corner, which is circled with uh, reddish color, and I want to find a adjacency between these two pixels, which is shown here at the bottom right corner and top right corner. I want to find the adjacency and path between these two. So let's first find all the four adjacent locations. If I talk about this pixel at the bottom, what are the four neighbors? Four neighbors of this pixel is this, and some pixel, if available on this side, it might be also the four adjacent. One pixel on the bottom, this also going to be four adjacent, but there are no pixels, so only these two, this 0 and this 0. These are the only four neighbors. But if you observe, these four neighbors are 0 and 0, and these zeros are not available in the given set V. Hence, we cannot consider those zeros as a part of a path. Okay. Let's see. Let's see various other adjacencies, four adjacencies available in this current example. Let's talk about pixel 2. Let me erase this all. Let me erase this all. let's take an example of pixel 2. What are the four neighbors of pixel 2? What do you think are the four neighbors? This is the fourth neighbor, this is the fourth neighbor, this is the fourth neighbor, and this is the fourth neighbor. And if I ask you whether pixel 2 and pixel 1, which is here, this pixel 2 and pixel 1, are they four adjacent? Please type in a chat box about your response. I am asking the center pixel 2 and the pixel on the right top corner, are they four adjacent? What is the definition of four adjacent? Pixel P and pixel Q are four adjacent. I will show you the definition once again. Pixel P and pixel Q are four adjacent if P is in the set N for Q or Q is in the set N for P. That means what? They are fourth neighbor of each other. They are fourth neighbor of each other. So can you type your response now? Are they four adjacent? The center pixel 2 and the right top pixel 1, are they four adjacent? Type yes or no in the chat box. Do it very fast. Manjunath is saying yes. Others, please type in the chat box. Come on, type yes or no. I am saying that the center pixel, this pixel is P and this pixel is Q. Can I say that P is fourth neighbor of Q or Q is fourth neighbor of P? What are the fourth neighbors of P? This, 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 and this. So can I say Q is fourth neighbor of P now? Yes or no? Can I say Q is fourth neighbor of P? I have already tick marked fourth neighbors of P. Fourth neighbor means what? Vertical or horizontal neighbors. Fourth neighbor means vertical and horizontal neighbors. So is Q a fourth neighbor of P? Manjunath? No. So Q is diagonal neighbor of P. In this case, you can see that Q is not a fourth neighbor of P. It is a diagonal neighbor, because diagonal means you see either in this direction or in this direction, plus 45-degree line or minus 45-degree line, right? So here Q is not fourth neighbor of P, and hence P and Q are not four adjacent. Okay, Q and P are not four adjacent. This is my conclusion. Uh, so if I want to discuss the same thing about another adjacency, that is 8 adjacency, can I say the pixel 2 is 8 adjacent to pixel Q? This is pixel P and this is pixel Q. Can I say these are 8 adjacent? Tell me very fast. Can I say these are 8 adjacent? What is rule for 8 adjacency? Rule for 8 adjacency? They should be 8th neighbors of each other. P should be in the 8th neighbor of Q, or Q should be in the 8th neighbor of P. So can you see whether P is the 8th neighbor of Q or whether Q is 8th neighbor of P? You see that all the around samples or all the surrounding pixels for the Q are the 8 neighbors of Q. So this P is also one of the sample which is in the 8 neighbors of Q. I can say that P is the 8th neighbor of Q, and hence I can say that P and Q are 8 adjacent. P and Q are 8 adjacent. Now this is a question for you. You tell me whether these samples are 8 adjacent or not. This is a P and this is a Q. Whether this P and Q are 8 adjacent, type yes or no in the chat box. I think everyone should reply. If you are listening to me, you should reply. Otherwise, just leave the meet. Don't listen anything. If you are silent listener and not learner, just leave the meet. Reply quickly whether P and Q are 8 adjacent. Manjunath is saying yes. Others? I'm waiting. I'm waiting for your reply. Everyone turn on your cameras. Turn on your cameras. I just want to see whether you are listening to me or just Prithviraj. What do you think? What about the uh, response to the question that I asked? Prithviraj. So why didn't you reply earlier? I asked everyone to post the response. Whether P is it adjacent to Q or not. You have to just type yes or no. Even after saying everyone has to respond, you are just listening. What are you doing? Attending a lecture or watching a YouTube video or attending some free seminar? It's for everyone. Please reply in within 2 minutes. My question was this: whether these two pixels are it adjacent or not. Reply within 2 minutes or leave mute. This pixel and this pixel. This is pixel P and this is pixel Q. Whether these two pixels are it adjacent or not. Manjunath has replied multiple times. So only one person is attending. Prithviraj has replied yes. Others. Solkar is saying yes. Dasgavkar yes. Rigved yes. Dabolkar yes. Pranali yes. Okay, so now you understood. If they are surrounded uh, to each other or the close to each other with eight neighbors, then we can say that they are eight adjacent. Now, based on the adjacency, we also have to talk about uh, eight path. Okay, so let's talk about eight adjacent neighbors of 2. What are the eight adjacent neighbors of 2? This one is eight adjacent neighbor. I will use highlighter instead. This is the eight adjacent neighbor. This is the eight adjacent neighbor. This is the eight adjacent of a 2. There are another neighbors of a 2 like this 0, this 0, this 0, this 0 and this 0. There are another neighbors of 2 which are not adjacent because for adjacency the samples or the pixels should be from the set V, and in set V we have only 1 and 2. That's why we can talk about the adjacency only about 1 and 2. Like we don't have 4 adjacent here other than this pair and from here to here this pair. This is not 4 adjacent. The bottom line this and this is not 4 adjacent. Okay, so for 4 adjacency we have only this pair and this pair. For 8 adjacency we have here to here, then here to here, then here to here, and here to here. These all are 8 adjacencies. For M adjacency, from here to here. Remember the rule for M adjacency. M adjacency says that there is a priority. First, you see for fourth neighbor. If fourth neighbor is available, you definitely have to go for fourth neighbor. In that case, you don't go for diagonal neighbor or it neighbor. If fourth neighbor is not available, then go for diagonal neighbor. In that case, the fourth neighbor of pixel P and pixel Q should not have any common element. Okay, so the M adjacency will be here to here. If you see carefully, there is no fourth adjacency possible. So let's see if they are diagonal neighbors. Yes, they are diagonal neighbors. And their fourth neighbors, which is this, 2 has a fourth neighbor 0 and 1 has a fourth neighbor 0. So this is a common neighbor. And on lower side here also there is a common neighbor, but that neighbor is not part of a V. That neighbor is not part of a V. So we can say that these two satisfies the diagonal neighbors, and their fourth neighbor has no common element which is a part of a V. What I am saying again, they are not fourth neighbors of each other, but they are diagonal neighbors of each other, and they don't have any common element which is a part of a V. Any common fourth neighbor which is common and which is part of a V. Such type of element is not available. So intersection of N4P and N4Q is 0, which is not part of a V, and hence we can say that this 2 and this 1 satisfies the M adjacency. This 2 satisfies the M adjacency because they are fourth neighbor of each other. This 2 satisfies the M adjacency because they are fourth neighbor of each other. And the last pair, which is, let me use pen now. The last pair, this and this, is not M adjacent. The reason is, for M adjacency, you first check for if they are fourth neighbor of each other. So first condition fails. They are not fourth neighbor of each other. Second condition is, you check if they are diagonal neighbors of each other, and P and N4Q should be null, which is not a part of a V. So you see that if they are diagonal neighbors, yes, they are diagonal neighbors. But the second condition, the AND condition, this AND condition is not getting satisfied. Why? Because the N4P for this element is 1, which is this, and N4Q for this element is again 1. So they have N4P intersection N4Q, which is the common element, which is a part of OP, and hence this condition is not satisfied, and that's why both the conditions for M adjacency are not satisfied. I will go to the definition once again. So in that case, I had something like this. I had 1 here, I had 1 here, and I had 2 here. In this case, we see that about this pixel P and pixel Q, they are not fourth neighbors of each other. So this condition is not satisfied. So I went to the second condition and I checked whether Q is in the set NDP. Yes, Q is in the set NDP. So this part is satisfied, but this part N4P intersection N4Q should have no pixel which is part of a set V. So I see that N4P are these neighbors. I will mark them by green color. N4P are these neighbors. This, 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 and this. And what are N4Q? N4Q are these neighbors. This, again this, and this. So N4P comma N4Q, the intersection has these two elements. One is this element and other is this element. And that intersection has this one element which is a part of a set V, because set V has 1 and 2. So intersection has these two elements, this one and this one. This is not part of a V, but this is a part of a V, and hence the AND condition, that is that intersection condition, is not satisfied, and hence the pixel 1 and pixel 2, which are these two pixels, these are not M adjacent. So let's see once again what we have so far. We have 4 adjacent pairs, we have all the 8 adjacent pairs, and we have M adjacent pairs of the same image. We are talking about the same image. Now let's talk about the path. So if I show you once again the four adjacent, I am talking about the pixel P which is on the right bottom and pixel Q which is on the right top. And here, as you can see, here as you can see, there is no four connectivity available. The four adjacency is not available. Hence, the path from here to here should not be available, because in the definition of path we see that the 4, 8, and M paths are based on the type of adjacency. So either of these three adjacencies should be satisfied. Then only we can connect between those pixels and say this is a path. So here there is no connection. Here there is no connection, and hence 4 path will not be available. We will directly go to the 8 path and M path. So for 8 path, we have already marked all the 8 adjacencies. So 8 path can be either this way and this way. This is first way, and other way is you go from here to here, and then here to here, and then here to here. This is other way. So there are two different paths available using 8 adjacency. One of the path is you go from the pixel 1 3. 1 3 means you can see that this is a position. X is 1, this is X direction, this is Y direction. So in this case, here at this point, the coordinate value X is 1, Y is 3. At this pixel, X is 1, Y is 3. So 1 3, then this pixel is 1 2 pixel at location X1 and Y2. Then 2 2, that is this pixel, and 3 3, that is this pixel. So I am talking about this path. This path has been written 1 3 1 2 2 2 and 3 3. So they are considering that this is a pixel P and this is a pixel Q, and they are lining a path between P and Q. The other path, as I said, is from here to here. So that is 1 3. So it takes care of 3 pixels: this pixel, and this pixel, right? So pixel at 1 3, pixel at 2 2, and pixel at 3 3. Okay. Okay. 1 3, 2 2, and 3 3. So this is other path. So this path has been written here. These are the two paths which we have in 8 adjacency. So now we have already discussed about M adjacency. In M adjacency, what I said, you take either horizontal or vertical path. If horizontal or vertical path is not available, then you take the diagonal path. So that's why this is the diagonal adjacency, that is M adjacency between lower 2 pixels. Then here is the vertical path available, so they are directly can be called as a M adjacent. 4 adjacent path is available, so that's why we can say that these are M adjacent. But this one and these two cannot be called as a M adjacent, because they are not 4 adjacent, and they are diagonal adjacent, but they have a common element in the fourth neighbor, which is a part of a V. So collectively, we have these all M adjacencies. M adjacencies. So M path is only one, here, then here, and then here. So we mark them as a coordinate values 1 3, 1 2, 2 2, and 3 3. And this way we have the M adjacent path between those given pixel P and Q. We will clarify this idea with some other example. Now let's see. Now this is a question for you. Listen very carefully. We are talking about the adjacency. Let's see, by using some bright orange color, pixel P is represented, and by using dark uh, brown color, pixel Q is represented, and we have to talk about adjacency between them. 4 adjacency, 8 adjacency, and m adjacency. Okay. And what is a set V? Set V has elements 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the first image in which P pixel is here and Q. I will use some other color. Let's say. Let me erase this. Right. This is a pixel P and brown color is pixel Q. Can you say these are four adjacent? They are four neighbors of each other. First, first thing is they are four neighbors of each other, and both the values 4 and 9 are present in the set V. So we can say that P and Q are four adjacent. Okay. Let's talk about 8 adjacency. Can I talk about 8 adjacent? Pixel P and pixel Q are 8 neighbors of each other, 8 neighbors of each other, and both the pixel P and pixel Q are in set V, and hence we can say that these are 8 adjacent. Now about M adjacency, what is the rule? Either they should be 4 neighbors, or the second rule is they should be diagonal neighbors, and their fourth neighbor should not have a common element which is present in V. Okay, so here the first criteria is getting satisfied. They are fourth neighbor of each other, and both the values 4 and 9 are part of a V, and hence they are M adjacent also. This is another image where pixel P is here, pixel Q is here, okay, and the surrounding pixel, some other pixel value 1 and 1 are given just for the sake of giving. Now, whether these are four adjacent, answer is no. Why? Because they are not horizontal or vertical neighbors of each other. They are diagonal neighbors, isn't it? So, let's talk about 8 adjacency. Are they 8 adjacent? We know that the diagonal neighbor means always a part of a 8 neighbor, isn't it? So as pixel P and pixel Q are 8 neighbors of each other, we can say that they are 8 adjacent. But we cannot directly say they are 8 adjacent. We have to look for whether both the 8 and 9 are part of a set V. Yes, both the 8 and 9 are part of a set V, and hence 8 and 9 are 8 adjacent. Next, whether pixel P and Q are M adjacent. So there are two ways. We first see whether they are four neighbors. No, that criteria does not satisfy. Then we will see whether they are diagonal neighbors. Yes, they are diagonal neighbors. Yes, here they are diagonal neighbors. But do they have any common element which is part of a V? Common element is 1. Common fourth neighbor is 1, and that 1 is not part of a V. As you can see here, 1 is not part of a V, and hence we can say that even if they have a common fourth neighbor, but that neighbor is not part of a V, and hence these are M adjacent. So I will go to the condition once again, and this is last time I am going to the condition. We saw that P and Q are not four neighbors in that present discussion, but they were diagonal neighbors, and we saw that N4P intersection N4Q was the pixel 1, and that pixel 1 was not a part of a set V, not a part of a set V. That means this whole line got satisfied, hence the M adjacency got satisfied. I hope you understood now. Okay. Now again the same example is given. This is P and this is Q. Again the same example is given, but in this example the neighbors are different. So what is fourth neighbor of 8 and 9? This is one of the fourth neighbor, common fourth neighbor, and this is another common fourth neighbor. Whether these common fourth neighbors are a part of a set V, any one of the common fourth neighbor is part of set V, yes. In this case, the both of the fourth neighbors 4 and 9 are part of the set V. Even if only one of them is in the part of a set V, then also we can say that they are not M adjacent. So in this case, luckily both the fourth neighbors are part of a set V, and that is easy to say that they are not M adjacent. So 8 adjacency is still satisfied because they are 8 neighbors of each other. 4 adjacency and 8 adjacency is easy to find. M adjacency needs little logic to work on. Now P pixel is given in the lower side here, P pixel, and Q pixel is given just above that. Are they 4 neighbors of each other? Are they 4 neighbors of each other? Yes. But still they are not 4 adjacent. What is the reason? Type in a one word or one line. Please type in a chat box. Pixel P and Q are 4 neighbors of each other, but still they are not 4 adjacent. Yes, the reason is they are both the pixels are not part of a V. The pixel 1 is not part of a V. So I hope now you understood what is difference between neighbors. Neighbors means just dependent on location. Adjacency depends on whether they are neighbors and they are part of a set V. And the third thing is path. Path is whether they are uh, adjacent by some of the adjacency, fourth, eighth, or M adjacency. And if they are adjacent by some of the rule and they are located close to each other, then we can trace a line between such of the pixels and we can say that this is a path. So to better understand 4 path, 8 path, and M path, let's take this example. This is one of the pixel. Let's say this is the starting pixel P and this is the ending pixel Q. And I am asking you find all the 4 path, 8 path, and M path between those highlighted pixels. So now you should know what to do while finding 4 path. You either go horizontally or vertically by keeping on connecting all the pixels which are part of a V. Okay, so here the image contains elements 0 and 1 and set V contains only element 1. So my path should be connecting all the elements 1 which is a part of a V. So from P, if I keep on collecting all the elements which are 4 neighbors, so from here to here, I can collect this element because this is a 4th neighbor of pixel P. Okay, but if I from here, if I find another 4th neighbors, then there is no 4th neighbor for this element which is present in the set V. So I am kind of stuck here. I want to go from this pixel P to pixel Q by collecting all the 4 neighbors and keeping on joining them. But as I see here, I'm actually getting stuck at the pixel 1, which is shown by blue circle. So I cannot go for finding 4th path in this direction. Let's go in this direction. Here also I am getting stuck because there is no 4 neighbor for this element on vertical upward, right? So let's find on right side whether this is a 4th neighbor and this is a part of V. Yes, so collect it. This is a 4th neighbor and this is a part of V. Yes, then collect this also. This is also a 4th neighbor and part of V. Yes, collect this also. This is a 4th neighbor and part of V. Yes, collect this. This is a 4th neighbor of that and part of V. Yes, collect it. Then for this sample, is this a 4th neighbor and part of V? Yes, collect that. And this also. So we reached from pixel P to pixel Q, collecting all the intermediate pixels which are part of a V and 4th neighbors of every adjacent sample. So for this pixel, if I talk about the just above and just below, there are fourth neighbors. If I talk about this pixel, just above and just below, there is a fourth. If I talk about this pixel, on right side and on left side, there is a fourth neighbor. So this way, I collected all the pixels which are fourth neighbors of each other and which can give me a path between P and Q, and thus we have a four path finally, and that four path is this. That four path is from here to here. We have to show direction. We have to show direction. So you can use arrowheads, one or two arrowheads just to represent from where to where I have found this path. So what is length of this path? What is length of this path? Just you just count number of steps. This is one, this is two, this is three, this is four, this is five, this is six, and seven. So there are total seven steps we took to move from P to Q, and hence the length of this path is seven. Okay, we will discuss rest of the things about H path and M path in this example in our next lecture. Before that, I will suggest you all to just have a look at this particular example. The link is there in the slide. The same example has been discussed on in that same video, YouTube video, so you can have a look at that. It will become easier for us to proceed with if you look at that particular video. So the link is available here. I will post that link in the chat box. Please copy that link and keep it saved somewhere at your end. Have a look at that particular video before coming for the next lecture. Once you copy paste this link somewhere at your end, type in a chat box copied, and then you can leave the meet. I will paste that rather in the here YouTube video link in the WhatsApp group also. So now it's easier for you. So let's stop. You can leave meet now. Thank you.